All right, we're going to talk about work problems from section 5.6. It says Omri can deliver newspapers in 81 minutes. Horace takes 66 minutes to do the same job. How long will it take them working together? Well, how long will it take them to deliver newspapers if they work together? All right. So on a problem like this, it's not a 6-cell table. It's not time for a 6-cell table. As much as I like 6-cell tables for work problems, for word problems, it just doesn't apply in this case. Here's the formula, and let me tell you, everyone at this level of math should learn this formula, should know the formula. It's kind of like I guess in that way, the quadratic formula, where you should learn, it's just one of the formulas you should learn. So here it is, the formula for work problems. 1 over A plus 1 over B equals 1 over T. It's not a secret. It's one of those formulas that every student at this level should at least have written down for, when they need it. All right. How does it work? A and B are the times working alone, and T is the time working together. So when we got this problem, one of the participants did the job in 81 minutes, so that's the time working alone, and the other did it in 66 minutes, so that's the time working together. 1 over T, well, T is what we're looking for. So you can just start by plugging into that formula, and you get this equation. Now, what further complicates things is the website casually says the LCM of 81, 66, and T is this number, 1,782T. This may be true, but it's not something we can find easily. In other words, we don't just look at 81 and 66 and realize right away that the LCM is 1,782. It's just not something that we do, or we're ready to do, we're expecting to do. So I say that might be true, but it's not something we can find easily, and it's not even necessary. So again, that is the LCM, but let's think about our goal on this problem. So I call this the best solution, and our goal is, you've heard me say this before, to do the same thing to both sides in order to create a cancellation. And what do I want to cancel? I want to cancel all the denominators. I want to cancel the 81, I want to cancel the 66, and I want to cancel the T. So what would work besides the LCM that the computer gave to us? Well, 81 times 66 times T will cancel the 81, the 66, and the T. I mean, it's one of those things that's kind of obvious once you put it in play. So what I mean by that is I'm going to take these three things and multiply each of them by 81 times 66 times T. So I'm doing the same thing to both sides in order to create, in this case, 3 cancellations. So 81 times 66 times T divided by 81 cancels the 81. This cancels the 66, and this cancels the T. Now, I might lose, a little credibility here because I'm not using the smallest number. The L stands for least common multiple. Yeah, I'm not, and I'm okay with that. All that means is when we get to this line right here, our numbers are going to be a little bigger than they would have been if we had used the computer's number instead of this entire product. But it doesn't matter. And what I mean by that is if I divide by 147, I'm just going to use a calculator to do the last step. And so the last step is 5,346 divided by 147, and we got 36.4 minutes. I rounded it off to 36.4. I think it was 36.37, something like that. But run through this yourself, and when you come across this problem, you'll probably recognize it. It always has the same names. It's always about a newspaper delivery, but it might not be an 81 and a 66 for you. It might be some other numbers that would give you an equally challenging, least common multiple, but this procedure will pretty much be identical. All right, so that's my summary of, see if I can get the whole thing on the screen at once. All right, that's my summary of work problems. And I'm going to say work problems, most students actually don't mind them once they get the hang of them, because they all kind of work fairly quickly, as you can hopefully see. All right, 5.6, work problems.